Hello everyone. In this video, we will discuss the absolute gravitational potential energy and we will find out the value of absolute gravitational potential energy and we will also calculate the gradient of gravitational potential energy. Let's start. Here we have a setup in this the mass m. The object of mass m is placed at the distance r from the center of Earth, and the mass of Earth is taken as capital M and the mass of the object is taken as small m. As we know that the gravitational force is always towards the center of Earth, which is vertically downward, and if we take the object from distance r to infinity, then we will have to do work because the Earth is going to attract the object of mass m towards its center, but we are going to take it object from a point r to infinity. We have to do work done, and this work done is equal to the absolute gravitational potential energy. If we take the object from a certain height, a certain point to infinity where the gravitational force becomes zero, our work done will be equal to the gravitational potential energy of the object at this particular point. The first of all we have to do is this. So we have to calculate the work done to take the object from uh, point, let's say it's a point P, the point P to infinity. We know that the work done is equal to W is equal to F dot D, but here the force and displacement are variable, then we will convert our relation into F dot dr, as dr is a small displacement towards infinity from the point P. Now work done will be equal to integral F dr dot product is equal to F dr cos of theta, and theta is angle between the force and dr displacement. As our unit vector is upward direction and dr is also in upward direction, as we take the object from point P to infinity upward, vertically upward direction, and the gravitational force is vertically downward, the angle between the dr and gravitational force is 180 degrees, and cos 180 is equal to the minus 1, which will become the minus integral f dr. Now the work done is equal to minus integral. The force is equal to the, by Newton's gravitational law, is capital G, small m, the mass of the object, capital M, the mass of Earth, and divided by r square and dr. The capital G, mass of the object, and the capital M, the mass of the Earth, are the constants, and we will take it from the integral. Our equation will become minus capital G small m capital M integral 1 by r square and dr. The minus integration of 1 by r square will become minus 1 by r, and we will take the limits from point r to infinity because we are going from here to infinity. Then our lower limit will be the r, the distance from the center of the earth r, and infinity, the distance from the center of earth where the gravitational force becomes zero, is called infinity, out of the gravitational field. The minus capital G small m, the capital M, this minus and this minus will become positive, and we will left with 1 by r, and the upper limit is 1 by infinite minus 1 by r, and 1 by infinite goes to 0, our equation will become minus capital G small m capital M divided by R. And this work done is equal to the potential energy or absolute gravitational potential energy. Now, if we calculate the absolute gravitational potential energy at the surface of Earth, then our distance will be equal to from center of Earth to the this point. For example, this will be equal to the capital R, the radius of Earth. Our equation will become at surface of Earth absolute gravitational potential energy is equal to minus capital G small m capital M divided by capital R. Now we are going to discuss the gradient of gravitational potential energy. If we take the gradient of this potential energy, as we know that the gradient of potential energy is minus capital G small m capital M minus capital G small m and capital M will be out of this del operator, the minus capital G small m capital M, and we will left with del operator just 1 by R. And we know that the del operator of 1 by R, the gradient of 1 by R is equal to minus R unit vector divided by R square. If we don't know this result, you should check out our playlist of vectors, and we prove that the del operator for 1 by R is equal to the minus R unit vector divided by R square. You can check this video by clicking at the corner. Now we discuss this. The del operator of absolute gravitational potential energy is equal to minus this capital G small m capital M R unit vector and R square will become the gravitational force, which is downward, this minus sign here. As the gravitational force is downward, this gravitational force is downward and R unit vector is upward. They both have a opposite direction. That's why the gravitational force is equal to the minus of a R unit vector. The del operator of U is equal to the minus F gravitational force. From this equation, the del operator of the absolute gravitational potential energy is equal to minus F is proved that the gradient of absolute gravitational potential energy is equal to minus of gravitational force. Thanks for watching.